Okay, so the next lesson for this particular chapter and section is going to be dealing with power reducing formulas. So I've taken a problem from your textbook, problem number 27 on page 250. We're going to want to, it says, use the power reducing formulas to rewrite the expression in terms of first powers of the cosines of multiple angles. So first power of cosines just means cosine of something, and a multiple angle could be, cosine of 2x, cosine of 4x, cosine of 3x. Cosine of x is fine as well if you end up with one of those. But what are the power reducing formulas? So let's go to the PowerPoint slide. The next slide, slide 6, shows the power reducing formulas. And this can also be found in your book. These are on page 245 in your book. All right, so we're looking, all of these turn sine squared or cosine squared or tangent squared into things that deal with cosine. So our sine squared gives us 1 minus cosine of 2u over 2. Cosine squared gives us 1 plus cosine of 2u over 2. And tangent squared of u gives us 1 minus cosine of 2u over 1 plus cosine of 2u. All right. And again, the tangent you could see by sine over cosine is just, you could take this, the first one, and divide by the second one to get this value. All right, so we're going to be using this very first one, but we have a cosine of the fourth. But a cosine of the fourth power is easily broken up into a cosine squared times cosine squared. So we'll do that first. All right, so the very first thing we want to do is, what did I just do? Okay, sorry about that. Change cosine to the fourth power into cosine squared times cosine squared. Now we have the double angle formula for each of them. And I will write down the individual ones. So if you recall from the previous PowerPoint, this is 1 plus cosine of 2x. Excuse me. It's 2x all over 2. And the other cosine squared is the same. Okay, so now we're going to have to multiply these two things together. The denominator is 2 times 2 is equal to 4. So we're going to have a big mess over 4. So I'm just going to do the FOIL on this. 1 times 1 is 1. 1 times cosine of 2x is cosine of 2x. Cosine of 2x times 1 is another cosine of 2x. And then cosine of 2x times cosine of 2x gives us cosine squared of 2x. Okay, so I'm going to combine these like terms. So I've got 1 plus 2 cosine of 2x because I have 2 of those. And then I can make another double angle, a power reducing formula using this bit here. So that will turn into another one of these. So the only difference here is that we, in the first part, we started off with x. Here we have 2x. So we're going to have to take 2x and multiply it by 2. So ultimately, we're going to get this. I'm going to write the fraction up in there in this, even though it's going to look a little wonky. And remember, all of this is still over the 4. All right, I'm going to scroll down a little bit. So what can we do with this kind of a hot mess? Well, um, we can multiply through both the numerator and denominator by 2 to remove what we have um, down in the bottom there. So if I multiply through by 2, keep moving that the wrong spot. Okay. We have 2 plus 4 cosine of 2x. And since now the 2's cancel, so what I'm doing is I'm multiplying by 2 over 2. That's what I'm doing. So then we're left with 1 plus cosine of 4x. And all of this will be over 4 times 2, which is 8. So I can leave it like, well, it wants me to, question wants me to not have it in this form, so I can take out a 1/8. And that's going to leave me with the number 2 here. And this one's going to be 4 cosine of 2x. In fact, I can combine the 2 and the 1, so I'm going to make, and let's do this. I'll make this guy a 3. They've got a 2 here and a 1 here. So it's just 3. All right. And what do I have left? Another cosine of 4x. All right, so now we're done. And I mean, if you wanted to, you could leave this as 3/8, 1/2, and then 1/8 if you wanted to. I factored out an 8. Anyway, all of these are in the first power of cosine. Each of them is in a multi-angle, so our instructions have been completed, or we have completed what the instructions asked for.